Welcome back. We will continue the chapter 2, pointers and arrays. We have seen previously pointer definition, pointer operations, the null pointer, and arrays as pointers. Today we will see strings versus arrays of characters. So in C, there is no string type. You have two choices, either to implement strings as arrays of characters with the last byte being the \0, the null character, or by declaring and initializing directly strings using char pointers. So let's explore these choices. For example, we can declare an array of 10 characters to be filled later, either using strcpy or one by one filling. We have now 10 available elements. If we want to fill it, we can fill it with 9 characters because we will leave the \0's place guaranteed. Another example, you can declare, for example, an array called flower and directly giving the elements of this array without precising the size. Of course, as we have seen before, the size will be deduced and we will have our array of 6 elements with at the end the \0. Or either we can have a simpler version in which instead of giving the elements one by one, the characters one by one, we can initialize the array as a string, and even without saying that there is a \0, your \0 will be tagged at the end of your string. And you can even precise a bigger array size. For example, here message is an array of 100 characters and only the first 3 elements of this array are initialized. So we have all these 3 versions of the first choice. For the second choice, instead of declaring an array of characters, you can declare a pointer of characters and then directly follow it by the initialization of this string, which is in this case eva space h dot. So you will have your string exactly the size of the string you initialized with and with exactly the elements you provided, and name here is also a pointer for this array. So with all these choices, what are the differences? What are the resemblances? In your first choice, your elements can be changed, can be altered. In the second, if you declare using a char pointer, the elements are constant, you cannot change them. And as you already know, in the first choice, your pointer is an array, so it is a constant pointer. However, the second pointer is a variable pointer. You can make him point somewhere else. It's true you cannot change these characters here, but you can make the name pointer point somewhere else. So if you have a case in which your elements would not change and your pointer will not change, you can declare static const char name instead of declaring char star name. You can declare static const char star name equal and you initialize it. This way you will guarantee that your pointer is constant, it will not point anywhere, and being static it will be shared. Since it is constant, it will be used every time the same by the same function, so why not use a shared variable? Recapitulate what we just have said. In here we have a table of comparison of the array of characters with the char pointers. We will compare declaration and initialization. For array of characters, we declare using square brackets, and then we can use the string version. We can say equal hello between double quotes. For the char pointer, we have to declare char star and the pointer variable name, and followed by the initialization for sure. The effect of initialization, this is equivalent to declaring an array and initializing it on the declaration with the characters. And here in the char pointer, the compiler will create a string constant and will assign the address of the first element to the pointer. For the element alteration, if we declare using square brackets the array, we can alter the elements. For example, here we can change the first L to be equal to J, and if we print, we will see the result. However, in this red cell, you can see that this is forbidden to change the elements of the char pointer. We cannot say ptr of str of 2 equal j. Even if we write this in pointer syntax, it will not work. So, and this will lead to a runtime error, not compilation error. We will see in few seconds, because this will lead to a bad access. You cannot access those cells, you cannot alter them. If we compare the pointer alteration for the array of character, of course you cannot change the pointer. For example, you declare another array of 8 characters and you try to assign this another array value to your array tab str. This will not work. And even with a char star, this is not possible also. However, the pointer alteration of a char pointer is permitted, and you can easily change where ptr str points to. So here you are writing char star ptr 2 equal key fac, and you make ptr str equal ptr2. This is allowed. So now the constant key fac is pointed by ptr2 and ptr str, and hello is there in the memory, nobody points to it. And then you can also make your ptr str point to your char character. So also we have seen this in the previous section. This is also possible. Let's check. Let's go to the compiler and check. So here is my same code I wrote. If I try to uncomment and comment this declaration, they are the same. I can always change the elements. If I try to change the pointer, the array variable value, it will not let me. It will not let me see. The array type char8 is not assignable. And if I comment this and uncomment this, it will compilation error. For the char pointer, we cannot alter the elements. Okay, this is not good. We will see. Let us run. So we have run and there is a bad access because we tried to alter the third element of the array. So we have to comment this. We can continue easily with the rest of our code. And this was about our example. Let's go back and continue our lecture. So how do I decide which choice I should opt for? The answer is declare an array of characters of some size inside the function bodies when you need to edit the elements of S. For example, read and fill S from the keyboard, or concatenate to obtain to your elements, or copy from another string, or append later to the string. If you want the elements to be alterable, declare char s of some size. In the other cases, declare a pointer to character char star s as function parameters and when declaring constant strings. In this latter case, you should directly initialize. So this is our advice. For long strings, what if you have a string like a paragraph? How do you initialize it? The initialization of long strings can be split across line of source code as follows. You write, for example, this is your long string which is static and constant at the same time. Static constant char star long string. My name is Rudolph and the text will continue. You will close your double quote and open it on the next line. Work as a reindeer around Christmas time. Also, another line you close and you reopen. Up in the North Pole, my boss is a swell guy. He likes to give everybody gifts. So this is how we declare long strings, and then we can use them as normal strings. We cannot finish this section without mentioning the string.h library, which contains numeric string functions that you should be aware of these functions. And also we will see after the demo, we will see now how some of these functions is implemented. So let's begin by the demo. So here we have our demo program in which we declare two strings, two array of chars, because we will read them from the keyboard. So we are obliged to declare them as array of chars of size 80 each. And then we will read them using fgets, because the gets function is a dangerous function. They tell you it will lead to a stack overflow easily, because you don't precise how many characters you want to read. So this is easy. We will exchange gets with fgets. We will read inside S1 how many characters, maximum 80 characters, and from the keyboard, and also for S2. After reading this array of characters, we will put them in S1 and S2, of course, and then we will print them, and we will print along with them their lengths. And then we will move the \0 backward. We will leave the \0 at the end, but we will put another one directly before it. So this is just to remove the enter we were obliged to put when we type the characters, the array of characters in the keyboard. And then we will print them again, and here we should have both shortened by one character, and then we will compare them. This is explicitly done to show you, because I know there are many students that have weakness in the strcmp function. They don't really know what is the strcmp function's job. It is to compare choosing the dictionary order. So you give her the first string, the second string, and it will give you 0. It will return a 0 value if they are exactly the same strings. It will return something negative if the string S1 should come before the string S2, a positive number in the other case. For the first string, I will put enter. You will wait for the second fgets. I will write how are you. So obviously the first string is longer than the second. I will do enter now, and as we have been alerted, the first string is of 24 characters including the enter. The second string is of 13 characters, and then we removed the enter. They will become 23 and 12 character. If we compare them, S1 must come first in the dictionary, not because of her length or something, but because HE comes before HO in the dictionary. So this is the reason. S1 is less than S2. We said compare strcomp S1 and S2, put the result in comp, then we put the answer equal to 0 if comp equal 0, equal to -1 if comp is less than 0, and equal to 1 if comp is greater than 0, because we wanted to do a switch on the answer 0, -1, and 1. And in case it is 0, we wanted to print the strings are equal, which is not the case. The case is here that S1 is less than S2 in dictionary order, because strcomp returns something negative, because hello comes before how, and we don't even continue the sentence. All the sentence must come before all the sentence because of the first two letters. And then what we are doing, we are concatenating S2 on S1. So it will put inside S1 the concatenation of S1 and S2. S1 plus equal S2, but those are arrays of characters. So here you will see the output. Hello, my dear students, exclamation marks, and directly correlated with how are you, question mark. And then we tried another function in the library, which is strcpy. We copied into S1 another string, which is full replacement with semicolon, parentheses, and \n. and then we printed S1, and as you can see, full replacement enter are printed, and here I chose explicitly a sentence that is shorter than the initial sentence that was in S1. Hello my dear students, exclamation mark, how are you? Full replacement, as you can see, is much shorter, but it replaced the old sentence. Why? Because after the \n there is the \0, which is the string termination. So this is the important thing, the \0. strcpy will tag the \0 after this string. We will try two other functions in the library, strchr and strstr. Its strchr will check if a character is present in the string, and on the other hand, strstr will check whether a string is present on the string. Here, for example, the letter E is in the string hello, and the string hi is in the string hi there. Again, the stable there is in the string.h library strcpy, which copies s2 into s1 given s1 comma s2, including the \0 as last character. strncopy, which is the same but only copies up to n characters of s2. strcmp, which returns a negative integer if s1 is less than s2. 0 is if s1 equal s2, and a positive integer if s1 greater than s2 in the dictionary order. strncomp, same but compares up to n character. strcat, which concatenates s2 onto s1. This changes s1 but not s2. So here attention for strcat. If you pass to strcat and a pointer to string, this will not work. You must pass the array of characters pointer. So another strncat, strlen, strchr return a pointer to the first occurrence of the character ch given as a second parameter in s1, or null if ch is not present. strchr does the same, but the pointer points to the last occurrence, not to the first one. strpbrk returns a pointer to the first occurrence of any character in S1 that matches a character in S2. This was the subject of an exam. We told the students to write this function without including string.h. And lastly, strstr, which is the substring, return a pointer to the character in S1 that starts a substring. So it does not only return whether yes or no S2 is present in S1, but the pointer to the character in S1 that starts a substring that matches S2. So this also is a very important function. So let us see how to write these functions. We chose for you three functions from the easiest, strlen, and then strn, strcompare, and strcopy. So we will write this together now. We will see how they are written in the library. strlen takes as a parameter char star s and returns integer, which is the length of this string. It initializes a counter to 0, and while dereference s is not the terminating character, you increment the counter. When s points to the null character, the counter will not count this letter, so the strlen returns the number of letters in a string without the terminating character. Let us consider now strcomp. strcomp takes two strings and returns an integer which is negative, 0, or positive. So for first version, we will consider the array syntax, and then we will see how to write this in the pointer syntax. Let's first understand the array syntax. You take an index I and you iterate both arrays in parallel. So you take one index and you increment this index, and why you keep incrementing this index while the two arrays have the same letters in order. So while s of I equal t of I, you increment I, and if s of I equal t of I and happens to be equal to the null character, then you have iterated all the arrays and you return 0. Otherwise, you have exited the for loop because s of I did not equal t of I, so you will return the character subtraction between s of I and t of I, which is uh, negative if the first is less than the second or comes in alphabetical order before the second. So here notice we have declared I outside the loop in order to use it after the loop breaks. In the pointer syntax, what does this become? We remove the index and then we begin while dereference s equal dereference t, advance s and t pointers, and the same return 0 condition if dereference s equal \0, and if they are not the same anymore, so return the difference of their content. So this is the pointer's version of strcmp. Let us check finally the nice function strcpy, which is a very short function and very effective function. It takes two pointers to characters and it returns void. What it does, it copies the content of t into s. How? We initialize the index to 0, and while s of I equal t of I different than \0. Notice here what are we doing? This is an affectation. This is only an equal, not equal. We are not comparing s of I to t of I. We are putting inside f of I the value of t of I and evaluating the expression. The expression will return the value that was assigned. So while s of I receives t of I and t of I was not \0, so we didn't finish yet, increment I and then copy the next character from t of I to the next place in s of I. Okay, so this is it. You now can understand what is the meaning of equal inside the condition, because this is an expression, and while this expression is not equal to \0, why should this expression be equal to \0? It will be when the character copied is \0. The value of the expression is the value of the affectation. So let us write this in pointer syntax just like we did with strcmp. We will remove I and we will iterate using the pointers s and t, which are string pointers, which are character pointers. So as you can see, s of I is replaced by dereference s, t of I is replaced by dereference t, and instead of advancing I, we advance s and t themselves. So this is the pointer syntax, and by now you are able to understand this pointer syntax. Let us be more clever and make this function even shorter. So since this is post-incrementation, we will include it inside the affectation. So the affectation will be dereference s, dereference t, and put the value of dereference t inside dereference s, and then postly increment t and s. We have studied in the previous lesson or in the previous subsection of this chapter what does it mean when the plus plus comes without parentheses. It is stronger than the dereference. It concerns then only t, not dereference t. So we are post incrementing t after dereferencing it, and we are post incrementing s after dereferencing it. So this is exactly the same as the above. So here we have seen three of the functions of string.h library. The conciseness of the last strcomp and strcpy make them hard to understand. If you look at them, you will think this is very hard, but this is very easy in fact. And this reminds me of a statement which is of only one line, you are able to understand now. So the conciseness of the previous codes of the functions inside the string.h library reminded me of the statement which you can understand now. It is written, succeed is a variable that receives the return value of the function of the call to the function try. If succeed receives a 0, it means the function they try and did not succeed. This is a failure. So while not 0 means while 1. So while you receive 0 from try, you have to repeat while not succeed equal try. This is a empty while. So this is an infinite loop. Keep trying, and if you didn't succeed, you have to repeat trying. You have no other choice. Then exit from this loop when try returns 1. So the next two sections are very easy sections for you by now because you have watched all these sections. We still have to do arrays of pointers and void pointers. So see you next and stay safe.